Okay, I think we're ready to start. So welcome everyone. Thanks for being with us today. I hope not too much noisy here. Well, we do our best. You can hear us fine in the back. All fine? Yeah, perfect. Welcome to this session. We're going to speak about real time in big data and how it fits together. Maybe kind of trying to get into what's the value of combining this together. Is there a flywheel effect? When you start to combine real time and big data together. And a little bit of a history of the technology and what you can do today with technology like Redis, company I work for, and an open source ecosystem that we're part of. Me and myself, myself, Alexandre. I'm part of the solution team in Redis, working with customers to work on their Redis architecture, real-time architecture, and improving their application, performance, scalability, uptime, and real-time data scenario with Redis. Ali?
Yeah, hi, afternoon all. Alistair, Jarrett, spent the last 10 years at Red Hat doing microservices and transformation-y type stuff as a consulting architect, and recently came to Redis, so we'll talk a bit about data today.
Thank you, Ali. So, when we speak about big data, I think it's interesting to remember a few things about the ecosystem. For those of you who've been around for a little while, I would like to start with a little bit of history, and maybe it will become familiar with you, right? So, often when we think big data, we think about Hadoop, but you can't really find any Hadoop keywords into this floor. And we've been to big data events where the floor was all about Hadoop, right? And Hadoop is like somewhat hidden somewhere. And it was a big elephant, so it's not so easy to hide an elephant. But if you think about it, Hadoop started 14 years ago, right? It's kind of a shock. I'm getting old when I think about this. But 2008, Yahoo, started with this thing and created an open source ecosystem. Kind of interestingly, Redis started 13 years ago. And there's a lot of Redis on the floor. You've seen maybe Redis as part of real-time architecture or AI ML architecture. So let's speak a bit about why. So obviously when we started with Hadoop, it was all about reducing cost, to store more data. Primary use case at Yahoo was to store many logs. And have an affordable architecture to process the logs and extract some statistics. The industry started to adopt Hadoop as a way to reduce cost from the traditional enterprise data warehouse and run more modern analytics on more complex data. And it didn't fit in a table. We had to have another format, and we started to innovate from a storage standpoint into the Hadoop ecosystem. And then another wave of innovation came in to make sure we could process the data more intelligently. So there was more variety into the data, and the NoSQL landscape exploded in diversity. You had very specialized database, columnar database, NoSQL database, JSON database, time series database, and so on. And it became a little bit complex. And while we did this as an industry, I don't think we solved a key problem, which is how do we create value as a flywheel effect, right? So if I'm storing a lot of data, sure, I can run a lot of statistics and analytics on it, but we know that models die in PowerPoint, right? Just as they die in Tableau or they die in Power BI or whatever. The model and the analytics have value when I go back into the application flow, into the transaction flow, right? In essentially the real-time data that was there in the first place to generate the model and kind of train the model. So, mixing the two sort of makes sense. Many scenarios, have emerged. So depending on your model, you might be interested into maybe fraud detection. So, if you can move from, fraud analytics to real-time fraud detection and interception, same thing for, credit scoring, transaction scoring, it's better. So you need to kind of combine massive volume of data, massive volume of analytics in machine learning, but still, make sure the flywheel effects comes in and take that model and make sure it has an influence onto your real-time transaction flow, right? Same thing if you do like social network and you do, sort of profile recommendation, matching users together, etc. You can do a lot of, user profile analytics, but it has value to your user community when you can do this real-time matching. And sort of bring that value to the user. So, these problems are definitely not easy. And if you think, about what you've seen over the last 2 days, I think most of the industry is focusing on this. They're focusing on how I can take more data that is a little bit more real time, and you can see a lot of technology stack that are having event streaming as a core value proposition. How do I make sure my data scientist team can bring more model into the platform, and how can I make sure that the whole thing is still reasonably easy, and how can I have a platform instead of me integrating tons of technology and toolboxes, and having a very, very heavy technical depth to kind of build that stack, right? So we're gonna talk a little bit more today about the role of Redis into that thing, and how we think the next decade of convergence between real time and big data will happen. So Ali, if you don't mind, join us, and let's chat a little bit about Redis. Yeah.
Yeah, hi all. So I've got the job today of just doing a bit of the education side of things on what Redis is and how we work, and then I'll pass back to Alex. So for those who are not familiar with Redis is essentially an open source NoSQL database which natively supports a variety of different data structures and data models. It was originally designed for performance and high throughput for a majority, a lot of different use cases across, transactional, operational, and analytical workloads. And it was, over the last 13 years, popularized for essentially being one of the fastest data stores on the market, but also the ease of use. And more recently, we've been focusing on our capabilities to transform the different types of databases, the different types of data structures in which you can utilize with your applications, and to allow and introduce more accessibility into the open source market. We've recently introduced something called Redis Stack. So I hope most of you here are kind of familiar with Redis to some degree or not. But essentially, Redis Stack is a consolidation of capabilities from leading Redis open source data structures and some of the new enterprise data structures we're bringing in. So by that, I mean things like JSON, time series, graph, probabilistic data structures, and even SQL like querying. These are all now achievable within Redis. So we're kind of touting ourselves more as a kind of multi-model platform rather than a kind of fairly single-tenanted key value store. So our Redis Stack packaging also includes a bunch of developer tools for you. So Redis Insights comes out of the box. Redis Insights is a visual way of interacting with Redis, allows you to build your queries, interrogate your data, debug some of your server-side execution as well. So it's just a very, very easy way for developers to get hands-on with Redis and dig down into the detail. So we've got a number of pillars that obviously the way that we build our application, and performance is for us absolutely key. So in terms of performance, up here I've just got a benchmark for you. This benchmark was from 3 years ago, and essentially what it does, and what we're saying here, is we can articulate that, and when we talk to customers, we talk a lot about linear scalability and the ability to scale Redis in a way that meets your customer demand. So for Redis, we can scale currently, and like I said, this is from 3 years ago, up to 200 million operations a second. So this particular benchmark was 100 million reads and 100 million writes across 40 AWS nodes. And this is retaining the sub-millisecond performance that we're talking about. So when at Redis we talk about real time, we're talking about sub-millisecond response times. So not the tens, not the hundreds of milliseconds that you might expect from other databases. We are purely sub-millisecond performance. Now, something that's been coming into prominence this year is our querying and real-time indexing capabilities. So essentially, the way that we add new capabilities into Redis is through something called modules. Now, modules are additional data structures or additional capabilities that we can bolt on to the original Redis core. And in particular, Redis JSON and Redis Search have been extremely popular for the last sort of couple of years. Redis JSON, as you might imagine, introduces a document DB capability into Redis, so you can natively store JSON documents, and all of the capabilities that you might expect from a document database is now available for you to utilize in Redis. And more interestingly, you can couple that up with our Redis Search, so query performance and real-time indexing. So from the Redis Search perspective, what you can do is you can create secondary indexes. So these secondary indexes focus on different elements of your data structures that you'd like to be able to query. And that's in a real-time perspective as well. So existing data sets, as well as streaming into the platform, we can index in real time. So it means that as you execute your queries, so full text searches, fuzzy searches, wildcarding, numerical ranges, and even vector similarity, these are all now available out of the box for you to utilize. And like I said, it's a SQL-like syntax that you can use as well. So if you're migrating, say, from an existing relational database into Redis, then the migration is actually fairly straightforward there. I should just also mention as well about vector similarity. So vector similarities is something else that's come to prominence a lot this year. So you may be aware of kind of what vector similarity is and how it works, but if you do something like a Google image search, for example, that's a very, very similar implementation. So what we do is we take a complex data structure and we look for relationships between those complex data structures. So for example, if I give you a kind of more specific use case, if I have a complex data structure that represents a customer and I want to understand the relationship between those customers and the products in which they're buying, we can use vector similarity to understand similar customers, the products they've bought, and then use things like or do recommendations and suggestions on alternative products that they might be interested in. And I should also mention that Capital One are an example of a customer who have been using Redis Search now for the last 2 years and utilize it extensively across their microservices architecture. So performance and scale typically come at a cost. And as we transition a in-memory database from tens of gigabytes to hundreds of gigabytes to even terabyte scale, from an infrastructure perspective, this can be expensive. So at Redis, what we've been looking at is something called Redis on Flash. I say looking at, what we've got is something called Redis on Flash, and this is a tiered storage implementation. So what this means is you can have your Redis instance straddling both your memory and your SSD drives or your NVMe drives. So you've got your hot data sitting in memory, and then you've got your warm data sitting on your NVMe drives. And we use something called SpeedDB under the covers on the storage side. So should you want to query data that's on your actual SSDs and NVMEs, the performance is still extremely quick there for you to use. Now finally, from myself, just as a Redis Enterprise perspective, what we do is we provide best of breed from open source, as well as all the sort of modules and the capabilities that we've been building. And we package these into a form factor that allows you to that's a form factor that's essentially cloud agnostic from us. So whether your strategy is public, private, multi, hybrid cloud, that's all capable with Redis Enterprise. Sorry, let me just scroll quickly. Oh, no, sorry. And then I should also mention, from a Redis Enterprise perspective, we aim to be as transparent as possible. So whether it's automation or whether it's failovers or whether it's zero downtime, doing upgrades and things like that at runtime, these are all capable with Redis Enterprise. And I should also finally mention that from a deployment perspective, we offer managed services, so on all the hyperscalers, as well as doing your on-prem deployments as well. So I'd now like to pass back to Alex. He's going to talk more about how Redis plays into the analytical space and a little bit more about our server-side capabilities.
Yes, thank you, Ali. So obviously we have speed, scalability, and simplicity. But how do we go beyond real time? Having massive ingest and write capacity, having capacity to maintain real time analytics like real time counters as the data is coming into Redis and querying this counter at massive scale. We know that an architecture is a little bit more complex than that. We need to integrate with the broader ecosystem. So when we think about data, we may still have some traditional database, traditional SQL database and relational database. And when data is changing in this database, it might make sense to update the view we have of the data in Redis, right? So that I can continue to kind of massively query my Redis and have speed and scalability from data that is coming as fast as it can from the backend, where maybe I have a legacy backend that is still on a relational database. Think of it like maybe I'm running SAP Commerce. It's rely on traditional database. I have a stock inventory that is changing because of my legacy process. That is like an offline, customer care kind of scenario. And I want to make sure my stock inventory online on my mobile application is just refreshed as fast as it can, so that I can continue to serve the customer on the online scenario. So in Redis, we've come up with a change data capture framework where we can connect to many flavors of this backend system using dbzium, which is an open source change data capture framework, and we made this kind of full part of Redis Enterprise so that we could essentially listen for these changes from the transactional log of this database and move that data as fast as we could into Redis, so that you can then search for that data in real time. So that's kind of like one flavor of the integration we can do, very, very important as we introduce real time into a platform. The next kind of integration example we've done is with event driven architecture and event streaming platform. So we've done a contribution to Kafka, work together with Confluence so that we could get, essentially a plugin for Kafka Confluence for Redis, where you can consume from Kafka and write to Redis, or listen from Redis and update an event into Kafka, and continue to use, Kafka and Confluence as your, broad kind of data distribution platform, while, essentially ensuring you could, essentially free the data from any silos and connect the data into the broader domain using a platform like Confluent. If you think about it, these are like just two examples of how we've done some integration. But when we start to integrate things, usually we like to think about, what's the meta framework, what's the architecture. And maybe some of you are familiar with Lambda, Kappa, Delta, yeah, a little bit. I see some of you acknowledging this. So let me reflect a little bit on this, right? I mean, when Hadoop started, etc., we were really focusing on solving the batch layer, right? It was all great, but we were like mostly working offline, building data lake, making it less expensive, and having massive compute capacity on this one. And then we said, hey, you know what? We should make sure we have a speed layer where maybe some real-time data comes in parallel of what's coming into the data lake, because I can maintain some real-time statistics. And the first use case for Redis back 13 years ago as an open source project was actually log analytics in a massive telco. This is how the project started. It was started sort of similar to Hadoop in a similar time frame, and really into the speed layer, while Hadoop was essentially, trying to resolve a similar problem, but on a different scale into the batch, layer. And so this is why I like kind of this Lambda architecture. And of course, the value, like we said, for the flywheel effect, happens when your application domain can leverage, all these real time in, big data that you have. So this is kind of the value of the serving layer. So this is Lambda architecture. If you go to, others in the industry, they may have different flavors of it. A little bit more event-driven, and you end up with Kappa, a little bit of more materialized view on the data, and you end up with the Delta architecture, right? With the Delta Lake, right? You've heard about it maybe today on different sessions. So obviously, Redis plays a role into this, like we discussed. Very, very sweet spot using Redis on the speed layer, massive ingest, can do server-side compute, and lots of value for using Redis as part of your application domain, for microservices, deployments, and making sure you have high quality of service, high uptime for this microservices-based architecture. What we've done is also adding sort of capabilities for the BI ecosystem to integrate with Redis and be able to query Redis from the BI ecosystem, like Power BI, Tableau, etc. Usually these tools have a SQL interface. They do SQL queries. So what we have is essentially a translation engine from SQL to Redis search, so that it can do integration into this analytics dashboard. One of the emerging thing we've seen is also the emergence of the AI ML stack. And I think you've seen maybe over the last 2 days a big focus on the industry on making sure this ML ops pipeline becomes like a reality. How you sort of work with the data scientist team, create models and move these models into production, right? In a frictionless way. So quite interestingly, Redis has started to be also front and center to this kind of architecture. Uber, LinkedIn, DoorDash, many of these companies have started to provide some open source framework for feature store and MLOps platform. And pretty much all the time, Redis is the online feature store in this. So let me, detail a little bit what it is and what it means. So if you think about, an AI ML-centric MLOps platform, you have your data scientist team that would crunch a little bit the data, come up with models, right? AI ML models, that they kind of fine tune. So if you think about fraud detection, what you want to make sure is you intercept the fraud, detect the fraud, and avoid false positive, right? Because otherwise, you would kind of intercept the wrong transaction and flag it as, possible fraud while, it's a normal, customer. So, they would sort of iterate on these things and end up with a model that they think is good to go for production, right? So if it's good to go for production, they still need this, low latency, high performance sort of aspect so that the model can be served in production, right? So that's the whole concept of feature store. It's like an opaque format database, essentially kind of storing an opaque binary format and making sure the algorithm in production can access that sort of like online format and assess the transaction against that model, right? So, that's what feature store are all about. And you can find, Tecton, Feather, the reference architecture of Feather on Azure, all based on Redis, right? The interesting characteristics of feature store is they are pretty big. As soon as you deploy feature store, you have kind of like, lots of training going on in your model. When you snapshot your model and you start to have this online feature store database, usually it's 0.5 terabyte minimum, right? It's just the way the algorithm and the opaque structure is working. But it's a very, very important scenario for the industry. And I think this is the emergence of this flywheel effect, beyond the basic real-time analytics and counters that we could do even 10 years ago with just Redis, having an AI ML flywheel effect, moving your AI ML to production and having a way to have, real-time serving of that model is really important. So, putting this together, Redis is an ideal platform to go from like simple things like in-memory caching, key value pair, etc., to complex things where you have multiple domain experts from the data scientist team, from the application and microservices team, and from the big data and operation team, kind of working together to establish this flywheel effect and unlocking the the value of the data into these platforms. So, the question we often have is, how do we start? So, tons of resources online. We have a developer portals. We have a fantastic demo on feature store, vector similarity search as well. You can find us at the booth over there. We have, free content on, Redis University. Whatever the language you're using, you can try Redis. We have also, Redis Cloud available online. And the interesting one is Redis Launchpad. So this is like a catalog of application examples that was not built by us, but it was entirely built by the community. Every 6 months, we do a hackathon and a community-driven innovation with some, context and rewards. And we had, tons of contribution from people, building apps with Redis. There's a pretty cool apps that is looking after, I think, packet file coming from the New York City bike, data points, and building analytics around the bike density so that you can sort of forecast where to put the bike back every day, right? And that sort of use case where you kind of start to have like real time and big data coming together. So definitely have a look into this. I think that's all for today. We have some time for questions. So feel free to engage. We can move on with the mic, or just come visit us here. Again, we have a booth over there if you want to stop by. And thanks so much. Enjoy the day.